Not really.
Okay. Whoops. Wait, okay, let me go forward. There we go. All right.
I can't see anything right now.
There we go.
Okay. Okay. Wait, do I need to stand up or
No, no, you can sit. You just need, I just want to make sure you were like that the laptop is close to the voices. That's all.
If you want to, you can turn off your camera. You don't have to keep it on.
No, we're keeping it on.
Please not.
We can turn the camera off, so all that we do is the voices. So I think, did you already turn it off for us, Sandy?
No, you did not. Stop
Did it?
video at the top.
Where am I? Oh, there we go. Stop my video.
Okay.
Okay. That make you happier?
Yes.
Okay, excellent. All right, go for it.
So this image is a small volcano field with a whole bunch of craters. The biggest volcano in the upper right corner is really old because it has a lot of younger craters on top of it. Aside from like the few volcanoes and craters, the like surface of this picture is relatively flat, which I thought was really intriguing. Yeah.
Just like Kansas.
Oh, wait.
Okay, so this is a bit of a rill or like a lava tunnel. It looks like the rill at the corner looks like it like spit out or something hit it and it spewed everywhere. An asteroid may have like skipped like a rock or perhaps like dust from an impactor thrown at the rill. Yeah.
And for this image, there's a lot going on. Okay, we're gonna do it step by step. There are a good amount of craters, but not like as many as some of the other images. There's a lot more hills, like, or mountains, and then there's one like sinuous rill which like goes across it. And you can see that the hills are a bit older because they have a few more craters on them than like the Mare does. And the crater in the center of the sinuous rill is definitely younger than the rill because it's on top of it. And there is like a valley over the mountains above the rill and crater, which is just cool to look at.
I use my hands to
I think that's, yeah, that's
So
all
are we gonna
the,
stop there?
Yeah.
Or, like,
It's about
okay,
150 kilometers.
You did that with your hands?
Yes.
okay.
Okay.
so we'll start back up. So we'll take a break and then we'll do the asteroids.
Okay.
Oh gosh.
Okay. Thank you. So just one comment right away. Go back to that first moon image.
If I can.
Just start from there.
It won't let me go backwards.
Oh,
Apparently can go. Oh, there we go. The first one.
All right. So I'm just curious, what's the deal with the gray band on the right there?
Gray band.
Are you not seeing that?
Wait.
Oh, the gray band on the right. It's just because the image didn't seem to like it didn't take up the entire slide.
Oh,
Oh
gotcha.
yeah, that's we didn't want to
Gotcha.
distort it, so we didn't fill up the whole slide.
Gotcha. Okay, gotcha. So first of all, when you're talking about an image, and like you said in this case, you said the volcano in the upper right, the big one in the upper right. That's good, but you should mark that somehow.
Okay.
I mean, just circle it or point an arrow at it or something, you know. And in this case, because you've got some room, so to speak, because of the image is a square, you could use that right side to put some text, right? You don't have to put a lot. You don't want to put a lot of text, but just some major points, you know, whatever your major points are you want to make about the image, you could do that. But annotating, circling things, pointing things out, because as you're speaking, people will be looking at this and they're going to be like trying to figure out what you're talking about while you're talking. So they're going to be focused on trying to figure out the image instead of hearing you. So it's this balance of you want them looking at the image, but also not having to look at it so hard that they're not hearing you.
Yeah.
That's one thing. How did you decide? Okay, step back. So you talked about this as a volcanic field with a lot of volcanoes, but then you said something about volcanoes and craters. And you should be able to just use your cursor, your mouse cursor. Point to some examples of volcanoes and examples of craters for me.
So which ones were like that one there was one of the volcanoes, where some of the other volcanoes, and which pieces were you saying were the craters that were on top of them? And any of the three of you can do that.
I think
Right?
those might just be wait, you know how volcanoes on Earth have holes on top of them? I think that
Like
might just be the
caldera?
hole for, yes, that might just be the moon caldera.
Well, someone come up and look at the image and see if you can point to like one of those things that using my cursor there as to what might be, like we had said, you guys had said that right up there was a volcano. Some of them are volcanoes, and then some of them have, a couple of them do look like they have those.
There is a crater right here on the far side of it. And then way down here, there is one tiny crater. Very, very small. The cursor almost covers it.
Okay, so then every other circular thing you see here is a volcano.
No.
Okay.
They might also be hills.
Okay,
Yeah.
I got you. So it's some kind of raised feature versus a depression.
It's like a scattered mountain range, but hills.
I honestly can't tell, like the perspective of it. It could be a crater, it could be a hill. It's really weird. Like,
What?
I have no idea.
Okay, so let me ask you this. What piece of information that I will tell you you do not have I did not give you, what piece of information would help you better decide that? Come to it, just make a decision on what you just said.
On what I just said?
Yeah.
I
What would
think
help us better identify what exactly those features are?
I mean,
I
I
was
don't know. I just have to look at it more because, like, right off the bat, I do see a lot of craters, but then when I keep looking at it, it keeps not
Oh.
looking like that.
Okay.
going to try to zoom in, but that doesn't work.
It's okay. You don't need to zoom in. You don't need to zoom in. Okay, so if I were to tell you that in this particular image, the sunlight is coming from the left. If I tell you that, which it is, the sunlight's coming in from the left. With that information, what do you think you're looking at here?
A volcano field.
Oh.
Wait,
Oh,
Right.
it's just oh my god. No. No.
Can you see where there are craters if you know the sunlight is coming that way?
Here,
Yeah.
here,
Yeah,
here,
oh my
here,
God.
here.
That
Here,
So what are these?
maybe here. Craters.
yeah.
What kind of craters?
Um,
Mm.
um,
Impact or volcanic?
Is it complex ones?
yeah. Well,
Small ones.
dang, I did not
Well,
expect
look at
that
the scale,
perspective
small
there.
ones are definitely very answer.
Uh,
Small ones are generally what kind?
oh yeah, meteorites.
Like simple impact craters. Yeah. I don't know if you heard what I just said. I'm sometimes
simple?
can't tell if I'm. So yeah, I'd say like the smallest ones are like the simple craters.
Yeah, so these are all simple craters. Every single circular feature you see in this image is an impact crater. They're simple impact craters. Um,
Oh, wow.
So that's wrong.
Yeah, no, it's just changes perspective. That's why
okay, I can't hear the folks in the back.
yeah, it
Okay,
really
but
changes perspective to know where the sunlight's coming from.
Yeah.
Yeah,
Because it could be either at this like without
yeah,
knowing where
exactly. Right. So I did it on purpose because I just like to hear what people say, how they justify it, you know. And then I lay it on them that these are actually all craters. And the little
Hey,
out there
That's
near the
mean.
that's not mean. That's actually really a good idea. That's really thoughtful.
No, I hate that.
I love
Hey.
it. So
hey Lisa,
You
can
can't
you
be
point
wrong.
can you point to Apollo 12 for me?
I do what?
Point to the landing site.
What
Remember
am I pointing at?
the landing site? Remember this image?
Oh. Yes. I can see the trails.
Mm-hmm. There.
It's right there, right?
Yeah.
That's the first thing that you tagged as the crater, that you thought was a crater. So
That's
see
that's the Apollo 12 lander. So that's where the second mission to the moon with astronauts landed. And that was in November of 1969.
Um,
And
yeah.
so that's the part of the lander that it landed, and then when they left about half of it there, and that's the half that was left there. So then those what look like the linear dark lines that extend away from it and go around that crater. Those are the astronauts' footprints.
Oh,
What?
that's so cool.
We just made Leo's brain explode.
wow.
So
it's
and then
a combination
you
of
can
their
sort of see the
footprints.
trips they took out.
So it's a combination of their footprints and
Okay, we all did the
It's
exact
okay,
same
buddy.
thing.
yeah, don't worry, you're
The
learning.
thing is that I've seen these images 100 times, and you can tell I did not tell them what these images were.
No, yeah, so that's a pretty cool thing about this image is you see the Apollo 12 landing site in it. And the reason they landed where they did is because on the other side, almost on the opposite side of the crater from where that lander is, you can't see it, but there is a small robotic, meaning a spacecraft didn't have an astronaut on it, that landed a few years before, like 3 years before. So one of the astronauts, Alan Bean, trekked around the crater and went over to that. Well, actually, they both went out. Alan Bean and Pete Conrad both went over there and took a piece of it off, and they brought it back to Earth. So scientists and engineers could study it and see what the effects of, being in space exposed like that for 3 years to space, what it does to materials. Because in 1969, we had no idea. We knew almost nothing about things in space. We just didn't know.
Yeah.
So that's that image. And I will say anything in the future, any kind of image analysis you all might do for your project, you're going to know where the sun angle is. That kind of information is just part of images. You're going to know. So that won't be a mystery. It'll be easy for you. Okay. All right, let's go to the next image. So in this image, you're right. This is a rill. It's a part of it's just a piece of a sinuous rill. So it's one of those, curvy, kind of looks like a empty riverbed, kind of. So this is a difficult image to talk about because the sun is almost straight overhead when this picture was taken by the spacecraft. So there's not a lot of shadows. So it's really hard to kind of see some things. But you were talking about if you're towards the bottom, it looked like maybe an impact or something kind of threw out some dirt, and that's what happened. If you look at this image in better lighting, you can see a crater that would have been responsible for that ejection.
Oh, I see it now.
So,
Yeah, the lighting does change that.
It's just, and over on the right edge, those things that are right up against it, they almost look like ovals or something. They don't really look like craters. In different lighting, those are very, very round. So
Oh.
it's a lighting thing. It's crazy. It's crazy. But that's the reason I chose this particular image, is because it's tough. Okay, next image. Yes, a lot going on. I love this picture. Because there is so much going on. And like you said, that larger crater kind of right in the middle of that is younger than the real itself, because it overlaps it. Very good. So if you're at the crater, follow the reel to the left. And then you see where it kind of comes up here and follows along that mountain. Keep going.
Oh, up at the very edge
Yeah,
there
right
before
right
it
there.
dips back down.
Right
Okay.
there where you're pointing, that arrow, right? Go up a little more. To the other side of, yeah, right. A little more, right there. That bend in the reel, that's that bend in the reel on the previous slide.
Oh.
Oh,
Wait a minute.
So the
So
previous
this, yeah, that
slide
little-
it's zoomed in to that particular area of this image.
Yeah.
oh my gosh.
Oh, that's so cool.
That's cool.
yeah, you can actually see the crater right on top of it there.
Incredibly zoomed out images of the moon.
So I like
Cool.
this image for a lot of reasons. One reason is just so put the cursor back if you will. Now go straight up from that bend, that elbow goes straight up, and there's a little cluster of craters there. Those are part of
Oh,
those
yeah.
craters that don't look like craters in the previous image.
Oh, okay.
And then just a little to the left of that, kind of roughly in that area, that's where the Apollo 15 astronauts landed.
The
So
lunar
that was
island?
the fourth mission to land astronauts on the moon back in 1971.
Ugly.
And there's a really, really cool video from that mission. They did this, look it up on YouTube. It's called, look up Apollo 15 Hammer and Feather.
Oh, I saw that on Wikipedia.
Oh, did you see that?
Wikipedia.
Because
It's really,
fun.
it's a very simple experiment that they did. But it's awesome. It's so cool. But anyway, yeah, so we got a rill, we got an impact crater, we got mare, the dark stuff that the rill, of course, is in, and then all the brighter mountainous regions, the highlands. So you told me that the crater, that larger crater in the middle, which is called Hadley crater, and then the rill is called Hadley rill. The crater is younger of those two. So how old is the mare and the highlands? How old are those two features compared to the rill and the crater? I'll give you a second to think about it.
I forgot what Mare is.
The Mare is
Why
that.
is that like darker stuff that's like the flat part behind?
So
Oh,
if you had to
it's-
put them in
it's
age
like
order,
really dark.
what would be the oldest thing in the image?
Of those four
Oh,
things,
I'd say Mare.
I'd say
Mare-
the mountains, because the Mare doesn't have that many craters.
Mare.
Actually, no, it does have a lot of craters. I don't know. I
Mare-
think the mountains though.
Okay.
You can
Mare
see the
rill-
craters. There's a lot more.
Wait,
There's a lot
yeah.
more.
What's the youngest thing?
The
Wait,
crater.
yeah.
The big crater.
Okay.
The,
Next youngest.
the
Rill.
the way.
The rill.
Yeah, the rill.
The mountain and then the Mare.
No, the Mare than the mountain. There are there's so many more craters on the mountain that are visible.
No.
Yeah.
Look at it. That's two against one.
That's my guess. That's my guess. But look at the
Now-
mountains.
Yeah, but look, girly, look at the mountains.
Really?
Have a
So-
knockdown dragon.
so thinking about the number of craters, that's a great way of thinking about this, right? The older a surface is, the more craters it's going to have. So that's great logic. So now you got to be careful, because this image is not is looking at a much larger area than like the first image we looked at, for example. So if you were to zoom in on any one of the areas within the mare, this image was taken back in the mid 1960s by an old, a spacecraft 50 years ago. If you were to take an image, which there are, that was taken by us, like the Lunar Reconnaissance Orbiter, which has been up there since 2009, where they can really zoom in, you would see a lot of craters, right?
Ow.
Because they're just at a scale you can't see in this image. Okay.
Mhm.
Another reason, though, just to argue that the highlands, the mountains are older than the mare, is just because the highlands, the brighter material, was the original crust of the moon. So when the moon first solidified, it was completely all of that bright material, the entire surface. And then about, what was it, 500 million years later, there were some really large impacts in large asteroids hit the surface of the moon, something called a late heavy bombardment. I think this is part of the readings. And those impacts didn't crack the surface, but what they did was weaken the surface enough that magma under the surface was able to eventually push up through it and flow out.
No,
Yeah.
the real.
So in terms of oldest to youngest, we've got the highlands, the mare, the rill, and the crater. So anyway, I love that image. Great image. Okay. So a lot of conversation there, but that's great. Just wanting to sort out a few basic things and just a couple of comments about presenting slides in general. So whenever you're ready for the asteroid one, go ahead.
Do we want to turn our video back off? It kind of looks weird
Oh,
because we're looking
yes.
at the
Fine.
Yeah, we can turn our video back
Fine,
on.
you've had it on for ages.
Okay.
There we go. Get rid of Andy's face too.
It looks like a conglomerate rock. It looks like bits and pieces of the rock was glued onto the larger asteroid. There are lots of different textures. So there are smooth areas and there are like areas that are more sandy and like dusty. And there's no craters, which is like a bit weird. Itokawa seems to be like an S-type asteroid. And then the types, C-type, carbonaceous, S-type, stony, M-type, metals. Yeah.
I can move this slide. Once in a while it won't go. Why is it not going? There we go.
You turn
This
on
is
the
my
video.
favorite one.
no.
I'm kidding.
Craters, and maybe some crater chains, which is here. Missing a lot of the boulders that the first image had. Parallel ridges are ripples of a very, very large impactor. The smaller craters are sitting on top of the ridges, so they are younger. This is the Vesta asteroid, by the way.
Last one.
Surface close-up of a rocky and dusty surface near the Shoemaker. No craters, lots of different sizes on the rocks, behind the rocks and stuff. The surface is rather flat.
Is that everything? That's the end.
Okay. So what do you think? What do you think I would say about your slides?
Same things.
Our video back on?
Yeah, just
Yes.
it's all about trying to help your viewer, right, your audience, helping them
Mhm.
as you talk and about whatever it is you're presenting. So, yeah, so let's start with this one. So yeah, so this is actually a very close up of the surface of the asteroid Eros, E-R-O-S. So one thing I didn't give you in these images that I did give you in the moon images is a scale bar, right? So just to give you an idea, the largest boulders that you see in this image are about the size of a house.
Oh.
Hmm.
Huh.
So this is almost kind of like maybe
We would
looking
never
down.
guess that.
Yeah,
One
this is
second.
about like looking down on a neighborhood. That's the kind of area we're looking at here.
Oh, that's
Kind of cool.
Not
way
not
different.
exactly a crowded neighborhood, but
This looks like two surface.
so you can probably see that it looks like some of those boulders are partially buried.
Oh yeah.
Kind of looks like that with some of them. Did you read in the readings? Did you read about the particular term they use to talk about how when you look at asteroids like Itokawa, for example, why you see a bunch of really big boulders, but they're kind of spread out all over the surface, and then it's like the spaces in between are filled in with the smaller stuff. Do you remember that? What they call that?
No.
They call it the Brazil nut effect.
The Brazil nut
I don't
effect?
remember that.
I've heard of it from somewhere else. I don't remember reading that little movie.
Why the Brazil nut?
But
Oh, interesting. So I don't know why they chose that, but a better analogy I like is you open a box of cereal. Okay. What happens when you when you get to the bottom, the end of that box, what comes out?
Dust.
Yeah, a lot of dust,
Oh,
smaller pieces. Where are all like the pieces, like the whole pieces of cereal? Where are they in the box? Or most
in
of
your
them?
stomach.
definitely at the top.
Yeah, they're at the top
Yeah.
or halfway through, right? Because they take up a lot of room, but there's still gaps between them. So all the smaller pieces that get the dust and stuff that gets busted up, they will work their way down to the bottom of the box. Gravity pulls them down to the bottom of the box. Well, it's the same thing with asteroids like this. They call them rubble piles, where gravity is pulling the smaller pieces down, and so the larger pieces just kind of are at the top. Rubble piles are relatively small, on the order of a few hundred yards, probably not even a mile in size. Maybe a little more than that. But what we think happened is these are, the Earth, for example, is a pretty solid thing, right? In the grand scheme of things. Rubble pile asteroids are not solid. They are made up of several chunks, huge boulders all the way down to real fine dust that really stay together just because of their own gravity keeps them together. So it wouldn't be difficult to go up to one of these things with a spacecraft and like extend an arm and push it, and you would see material just kind of start pulling away from each other, and then it would just all come back together again. It's a really bizarre thing, but that's kind of how it works. So it also explains the rubble pile, or that effect explains kind of why you see some of these boulders kind of partially buried.
Yeah.
So anyway,
So-
go ahead.
When Dart landed,
I mean, crash?
did the arm thing you were describing, did that happen?
So Dart crashed purposefully into the asteroid. And we have, so first of all, when you look at it, just the images that came back right as it was approaching it, right before it hit it, it looks a lot like that asteroid's a rubble pile. And there were some ground-based observations, telescopes on the ground on Earth, and I think some, and there was a some smaller satellites that followed the impactor that got some images, but you can see this debris just comes out from it because of that impact. And it likely disturbed a lot of the mass of that asteroid, where it probably all kind of really broke up a little bit, with the really small pieces really getting blasted out. Some of the larger pieces probably came apart and then probably came back together again. So yeah, so DART probably hit a rubble pile asteroid, which we didn't know that asteroid was like that till it hit it, basically. Okay, go to the previous slide, I guess, not the next one, but the previous one. And that is Vesta. So Vesta is also not a rubble pile. It is much more of a solid object, much larger, probably differentiated, meaning that it has internal, layers, a core, a mantle, a crust, all that kind of stuff. We're pretty sure we have some meteorites that came from Vesta. I think they're called Vestoids or Vestites. I don't remember. And you guys mentioned that those 3 large craters are on the left. I think you're the first group that has ever suggested a crater chain. I think every other time I've heard this presentation, groups suggest that it's like just 3 different impacts in time, which they could be. I don't think so. I think and probably argue this is a crater chain. Given that there's not a lot of disruption of any of those 3, they all kind of seem to be the same, their rims don't really seem to be all that much eroded compared to each other. Anyway, they call that the snowman for obvious reasons.
It does look like it.
Yeah, we argued that it was a snowman.
Yeah, and those ridges that you talked about, those are probably from a very, very large impact that hit, I think, the North Pole or Southern Pole of Vesta a long time ago. And those ripples were actually from, shock waves rippling through the surface, literally. So yeah, that's Vesta. And then back to the previous one, the very first one, Itokawa.
Then
There we go.
Here, so Itokawa. A rubble pile as well. In fact, it's thought that there's this weird angled shape to it, right? That little kind of a bend, an elbow in it there on the left. It's thought that right there at that bend, that little piece that kind of points upwards, that was a completely separate asteroid from the other part, and that there was some.
That does look like a crack.
That's just shadows.
Oh,
that is.
So there was probably at some point some kind of collisional. There was probably 2 asteroids pretty close to each other, kind of like that system, that double asteroid system that DART impacted. Probably pretty close to each other. Something happened that maybe they collided with each other, or something else came in and collided with them, broke apart, and they just kind of came back together. But that's 2 separate things. So anyway, that's an idea. We just don't know, but it's possible. And here you can really see that the Brazil nut effect thing, or the cereal box effect, which makes a lot more sense to most people. But one interesting thing for scale, if you look, well, first of all, in 2013, February of 2013, so almost 10 years ago, there was an asteroid that entered Earth's atmosphere, and it exploded over the town of Chelyabinsk, Russia. Do you remember this, or have you heard about this?
I think I saw the photo.
You've probably seen pictures, maybe even videos of it. Yeah, it was like in the morning, and it was really, really bright. But so it didn't make it to the ground, but it exploded in the air. And then all of that energy from the explosion just went down to the ground. It's thought that the size of that asteroid that caused that event was about the size of the asteroid that's hanging off the end of Itokawa there on the right. That one right there.
piece?
Yeah.
Oh,
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 Um,
wow.
Uh-oh.
so
That puts that in perspective.
little fun fact.
It,
Wait,
can you show us?
That's
I can show you some of that's the
Wow.
picture of
It
it
is.
coming in.
I
So,
think it was a crater.
oh,
yeah, I remember that. I definitely remember that.
oh,
have you ever heard
Yeah.
of the Tunguska event?
hmm.
Oh, yeah, that's the one I saw.
That's the one that you saw the pictures for, because
Yeah,
that's the
so-
one that had like, the trees flattened all
Right.
around it.
That was also in Russia. It was in Siberia back in 1908. And that was the same thing where there was an air burst and the asteroid exploded in the atmosphere. And all that energy went down and sent shockwaves down through the atmosphere to the ground and just leveled that forest.
oh my
Oh,
gosh.
that's wild.
Russian meteor, 1908
Yes.
crater.
Oh
Yeah.
my gosh. Look.
Dang.
If
That's
that,
So-
wild.
You know,
that's
so
late.
in a span of like 100 years, basically 105 years,
Late.
2 events like that happened, right?
Wow.
Where an asteroid entered the Earth's atmosphere, blew up from friction, tore it up, big explosion in the atmosphere, caused shockwaves to go through the atmosphere to the ground and cause a lot of damage. So an asteroid doesn't even have to hit the ground to cause damage.
Yeah.
But the NASA has a whole section of what's called planetary defense. DART was part of that. Actually, DART was part of that and the Department of Defense. It was kind of, I think it was a joint mission between the two of them. But there is a section of NASA that thinks about this stuff. Yeah. So anyway, all right. Good job.